So let's talk about floating point data types now. So we've already briefly mentioned floating point data types when we were talking about binary numbers. And so I think you guys have a pretty good idea that floating points are used to store fractional numbers. Well, they're used to store real numbers. So these could be often fractional numbers. So if you're doing scientific computing or solving equations, you're probably going to be using floating point variables. These can also hold extremely large numbers. So if you need to use a number that's a lot larger than you can hold in an integer, you can often use a floating point to hold that number. But mostly what you'll be using these for are fractional numbers. So let's look at what these are. First of all, float is 4 bytes, and so this will hold numbers that are about plus or minus 3.4 to the negative 38 to plus or minus 3.4 to the positive 38. And these are referred to as single precision. So this is where the IEEE single precision, IEEE 754 single precision floating point, that's where that name comes from. So the single precision is 32-bit because it's 4 bytes. And then we also have a double, which is 8 bytes. And so this one is the double precision, and it's 64-bit. So if you've been wondering why one float is called float, which that's a pretty obvious name, that we have a floating point number, so we're going to call it a float. But the double is a little less obvious, like why is that floating point called a double? The reason why is because it comes from this double precision. So if we want to declare a floating point number, we could, if we want to declare a single precision floating point number or variable, we'd use float, and then what's the name? Let's just call this interest. Or we could also do double interest. And so this first one will declare, so we're declaring that variable as a 32-bit single precision floating point, and the second one is a 64-bit double precision floating point number. And then you can see the difference in the range of numbers that these can store. So the range of numbers for the double is pretty big. And then there's this long double precision. The reason why there's an asterisk here is because this says that it's 8 bytes, but that's system dependent. Some systems it's more than 8 bytes. The minimum is 8 bytes. It could be more. The other thing with doubles is a lot of times when you go in and use scientific computing packages, so for instance with MATLAB, it might be like this with Python, but I'm not positive. But definitely with MATLAB, your variables are all automatically double precision unless you specify them something different. So this is, when you're doing scientific computing, the double is what you'll usually be using. And then we know how these numbers are stored. They're stored similar to scientific notation. So remember, we took the binary number, wrote the binary number in scientific notation, and then we converted that into the floating point number. And the other thing is all floating point numbers are signed. And that means that, so with the floating point, remember the first bit is either a 0 or a 1, and that determines whether the number is positive or negative. And so that's a little bit different from the integers, because remember with integers we could pick if it was signed or unsigned. So, okay, let's look at an example of floating point data types. So this is an example program, and we have our usual pound include IOStream because we're using cout, the using namespace standard, and then our main function. So we have a couple variables that we're declaring. One of them is a float, and this float is a distance, and then we have a double mass, and then we're setting these values equal to, distance is equal to this 1.49 e to the 11, and the mass is equal to 1.989 e to the 30. And then we're going to do the C out. The sun is, and then we print the distance, meters away, and the sun's mass is, and then we print this mass, kilograms. And then this is what we get for our output. So the sun is 1.49 e to the 11 meters away, and the sun's mass is 1.989 e to the 30 kilograms. And this is, we're going to learn later how to change the output, like how these numbers are displayed. Right now they don't look very pretty, so we're going to learn how to adjust that later so they look prettier. So let's look at what happens if we try and mix floating points and integers. You can end up with some weird things doing this. So let's start with, like, let's say that we have an int number. So we have an integer that's named number. And let's say that we try and assign a floating point number to this number. So number is equal to 7.5. What's going to happen with this is, since this is an integer variable, it's going to convert it to an integer, and it's going to do that by just truncating this 5. So what this is going to do is assign 7 to the variable, and the 5 is just going to be discarded. So 5 is discarded. And so this can cause some issues if you're expecting, like, let's say that you're expecting that to save it as 7.5, or some people think that this might round it. So some people think that this might round up to an 8 before storing it as an integer, but it doesn't. It just cuts off whatever your fraction part is. So even if you had 7.9, this would still assign 7 to that number and then discard the 9. So where this can cause problems is, let's say that we have this. So we have int I, so we have an integer, and then let's say that we have a floating point, so float f. So we have two variables, one's an integer and one's a floating point. And then let's say that we have f is equal to 7.5. And then for some reason we assign I is equal to f. Well, we're going to end up with the same thing that we had up here. It's going to store 7 to I and drop the 5. So right here, I is going to equal 7, and it's going to discard the 5. This can cause problems, especially when you're doing division and math, and we're going to talk more about that when we get to the math, but you need to be really careful if you're dealing with integers and floating point numbers, that especially if you're doing mathematical operations, you need to be careful that you're not assigning a floating point number to an integer when you think that it's still a floating point. And if you start getting into large programs that have a lot of math, this can be easy to mess up if you're not careful. And the main thing to keep in mind is, so when the integer truncates the floating point number, it doesn't round it. So don't assign a floating point to an integer thinking, oh, it'll just round it, because it's not going to. The other thing is floating point numbers can hold values much larger than integer data types. So floating point can hold larger values than integers. And so if you try and store a floating point number to an integer that's too large for that data type, it's going to store an invalid value. Like, it's not going to store what you think. So an example of that, like, let's say that you have a really large number, like, what was this mass? So 1.89 e to the 30. So let's say we have a floating point that's 1.89 e to the 30, and then you try to assign that to an integer, maybe a short int. So it's going to, first of all, only store the 1 because it's going to dump the fraction, but then this is a really large number, so it's going to store something that doesn't, like it's not going to be what you think. It's going to be an invalid value. So if you're working with really large or really small numbers, you have to be careful going back and forth between the different data types.